Good evening. I have 20 minutes to talk about artificial intelligence and how we're doing it at DNA. And if I look at it from an IT perspective, there's two main things why we do IT projects or why we do basically anything in an organization. It's either that we have a large-scale crisis or we actually understand that there's some possibilities that we could actually attain by doing something. Those are the main two things why we're doing stuff. And for us, luckily, we didn't have a large-scale crisis when we started doing artificial intelligence. Rather, that we actually understand that it might give us a competitive advantage if we started early enough and actually built it around the customer. So let's look at the journey. If you look at artificial intelligence in a broader sense, there's talk about Google inventing its own language. There's talk about the great AI awakening. That's a great article if you look it up in New York Times. It talks about artificial general intelligence, which means that there's a machine that actually understands like a person does. There's a Tesla engineer, there's a Tesla outside, saying that in a few years, we're starting to think that cars without artificial intelligence are going to feel a little stupid in a sense. Artificial intelligence is so combined with the technology, with the car, that it would make no sense to actually have a car without AI. JP Morgan is using artificial intelligence to replace lawyers, or rather remove the sort of really boring tasks from the lawyer's hands. And then there's even a paper on artificial intelligence writing its own programs. So basically, artificial intelligence writing more artificial intelligence. And this is actually really interesting because this might have some huge possibilities. But at DNA, we have the same sort of definition for AI as AWS does. So basically, it's any type of system that creates such intelligence that is usually perceived to be human level. And if we look at that, this is how we look at AI. Basically, we have two dimensions. There's stuff that's easy for humans, and then there's stuff that's difficult for humans. There's also stuff that's easy for machines, and then there's stuff that's difficult for machines. So if we look at how using data started out, we started with stuff in the reporting side. It was relatively easy to do for computers, but it was still relatively easy for humans as well. Then we moved to data engineering, data pipelines, moving data in real time from one place to another. This is really difficult for humans because we cannot process a lot of data. We can only process a sort of really fine amount of data at any given time. So it was more difficult for us. And then we moved to data science. And data science is basically statistics run on large amounts of data. And then sort of the last, it's almost paradoxical that it's the last part, that now we're trying to create computer services that do stuff that is really easy for humans. If you ask a computer to multiply the amount of let's say, 100,000 by itself for an infinite amount of times, it's going to do it relatively easy. It's going to return the result in milliseconds. But if you ask a computer that does it see a cat or a car within this room, it's going to have some difficulties, which is stupid, because if I put like a 2-year-old here, he or she is going to know if there's a cat in the room, but couldn't multiply a large amount of numbers by itself. So the thing is that AI, as all of data analytics, is a journey, and it's a journey at DNA as well. You have to do all of the parts. You have to do the basic reporting, you have to do the data engineering part, and you have to do the data science part to actually get into artificial intelligence. And we're just going to look at what artificial intelligence looks at DNA. It has sort of 3 dimensions. The first one is called recommender, which means that it recommends stuff. It makes optimization. It makes forecasts about the future. It uses hard numbers. And if we look at it, this is how it actually works. If we take TV usage data from our TV services, we can look at what is the best content that we could actually offer to any particular user. So for myself, if I look at SM-liiga at the moment, and if I look at NHL, the artificial intelligence side is going to recommend possibly KHL, possibly tennis, and so forth. It's going to know, based on other users' behavior, that I might like something that I haven't actually yet gotten to use. And we use this as a sales tool, and in the first pilots, we got around 3 times the sales that we usually get from any type of direct marketing. So it works. But there's another side. This is called Runeberg, after a Finnish poet, and it's different from its sister, because it wants to create understanding by understanding natural language, and this is more like artificial intelligence, and it makes sense out of social media. It understands what is talked about. It understands what are the topics that are talked about when people are talking about DNA. It can understand social media in a way that it can give us input on what is happening in a broad sense in our customer base. You don't need to understand what's happening there, but basically it uses part of speech tagging to understand sentences and how words actually link within that sentence. So if I ask, onko teillä iPhonea myynnissä, mitä se maksaa? It can actually say that within these 2 sentences, maksaa and iPhone relate to each other. So you can use this in a chat context really well, because it can understand dialogue. And then there's the third side, which is, we call it insight. And this is the sort of part that makes DNA data informed. And by data informed, I don't mean reporting in the basic sense, but I mean using advanced analytics to actually enhance reporting. And this is a picture of the tool. It's within Tableau, and we have calculated where to put networks. This is Tampere region, and we can calculate the possibility of our products going through in any particular area, and we can plot it in a map, which means that we can actually build the optimal route for our infrastructure based on a map, which is nice. because they are large investments. And that's the sort of combo. So you have insights, which makes us data informed. You have recommendations that makes optimization, which actually creates sales for us, which makes better marketing ROI. And then you have the artificial intelligence side, which understands natural language, and which you can use in a chat context. And then, as the most important part, we have Project Einstein, which means basically the data platform beneath. And within that data platform, there's a lot of stuff, first of all. And the thing is that we bring in all data in real time. So there's terabytes of data coming in so that we can report it within 5 minutes, and we can react based on it in real time. And then there's basically two sections. We have the basic reporting, and then we have the machine learning side. And then there's a lot of stuff, especially on the machine learning side, where people have been talking about R here. That's all good and fine, but when you have a lot of data, you eventually will end up with Spark or anything else, or TensorFlow, which is a Google product, because R is not going to be able to actually process all that data. But we still use it for some ad hoc analytics. And if we combine all of that stuff into one picture from a business user's perspective, then it means that we can be data informed within all of our silos, in a sense. There's ad tech and marketing tech, which we support with the recommendation systems. Then there's advanced analytics for segmentation and potential scoring. We have real-time insights for profiling and dashboards and actually seeing where our euros are going and where are they coming in. And then with the artificial intelligence side, we can actually support customer service really well, because when we understand natural language, it's going to be really efficient in a customer context, because in a customer service context, because the thing is that we need to understand that why are people calling us, why are people chatting with us, why are people emailing us, and we need to understand what is the problem with our service, that why people have to call us. And actually, you cannot process all that amount of textual data or spoken, even spoken data in any traditional manner. You need to build some sort of text classification tools and POS tagging on top of it. And I think the hard part is that you actually need to make the loop in a way that there's no gaps within it. So basically, this loops means the evolvement of data around the whole ecosystem. So when we do stuff in marketing, when we do stuff in customer service, when we do stuff based on the insight that we're providing, the data needs to flow between these sort of silos or functions. And this will actually give us insight on how DNA is performing within the market. But looks good, right? It looks good from a technology perspective. The problem still is that we've built all these cool technology tools for people to use, but people are still within the functional silos, right? We cannot remove there's still marketing people, there's still customer service people, there's still people who are designing our networks. We cannot say that, okay, now all of you guys are customer service, because all of you have the tools to be within customer service. We cannot do that. So now we have technology to support an ecosystem where the customer is actually in the center, but we still need to push the envelope in a sense that the people are going to act as the ecosystem as well. So, what actually makes good artificial intelligence, or what makes good business, at least for DNA? It's not the algorithm, even though it's generating a lot of sales for us. It's not the algorithm, even though it's helping us decide where to put networks. It's the human intelligence on top of the artificial intelligence doing the actual actions and operations based on that data. It's not teams, because I hate the word team, because a team within itself is a silo in a sense. A team knows something about a particular topic, but we don't want teams, we want cooperation. Teams are completely unnecessary. And we need IT business cooperation. This is sort of stupid to say because everyone says this in every single conference, but it's still, I mean, come on, it's really important from the change management perspective. Because if we build the ecosystems within IT, but we don't tell anyone in business, it's going to be a rather big problem. And I think the most important part of artificial intelligence, of analytics, of any sort of data usage, any sort of IT project, is the quote from Linus Torvalds, who says that 99% of this stuff is just getting things done. I mean, that's it. There's someone saying, okay, but artificial intelligence in itself, it's an innovation to use artificial intelligence in customer service. It's not. People have been doing it abroad for many years now. Now we are doing it, and that's fine. But it's just getting the stuff done. We are spending a lot of time talking about the possibilities of innovating within the artificial intelligence context, but it actually doesn't create any value to your business. It creates zero value if you don't do anything. And this is something we actually had to learn the hard way, because we spent some time planning, and after some months of planning, we saw that, okay, we have 0 deliverables for business. So we needed to just start doing. And as for artificial intelligence, it took us 11 tries to actually create a system that understands the Finnish language. We used Facebook's fast text, which is a text classification system. We used it with Google's SyntaxNet, which is on top of TensorFlow, if you know the product. We used a lot of different Google's products. We used latent directed allocation to understand text. We used a lot of stuff from Turku Natural Language Division from the university. And all of that stuff failed. Every single step failed, and there hasn't been a supplier who could have come in and said that, okay, this is how you do it, because this is the first time that we're doing artificial intelligence on top of the Finnish language in a really big data platform, within a data platform that actually holds a huge amount of unstructured data. So we failed. We failed 10 times, and on the 11th try, we actually succeeded. And now we have possibly one of the only ones in Finland. We have a system that understands the Finnish language in a really broad sense. And I'll be happy to discuss it with you after the event if you want to know more. Thanks.
Thank you, Jarmo. You really have to be optimistic, you know, to fail enough in order to succeed.
Yeah.
Is that the secret?
Yeah, basically that's the secret to everything, because you just have to stand up and try, and you're going to fail, and you're going to fail a lot of times, but eventually you're going to get that sort of understanding of how things work, that you're going to be able to create some magnificent things.
Thank
Yeah.
you.
Thanks.